So what do I want to get across? So I will get across today how long we live and what impacts the quantity and quality of our lives. I will speak about how exercise might extend the quantity and quality of our lives, and also how we can increase exercising in previously inactive adults, and does it have an impact on health? You're all familiar with the lifespan. We are born, and then slowly over time, after we have many successes, hopefully, and some setbacks throughout our lifespan, we eventually will die. There's nothing we can do about that. There has been some, about the death. There's nothing we can do about dying until there's a pill out there. There has been a really great study that was published a couple of years ago in the Lancet, and this is The Economist took their data, and it's hundreds of data points, and they summarized it into this beautiful figure. And right now, don't look at all the different colors. Let's look at the end of the red. This is the lifespan. This side is for women, and this side is for men. Let's look at the lifespan of women who are born in 2013 and how long it is expected that they will live, which is around 86 years old in Japan, and for men it is approximately 80 years old, 79 years old. If we look at United States, that changes considerably, where the health span is 79 years old for the women and 72 years old for the men. So that's our lifespan. That's the expected lifespan for the average person in Japan or the average person in the United States to live if they were born in 2013. But then there's also this concept of the health span. What is happening in our final years? What is happening during the period from as we're entering older age before we die? And now let's look at these colors, and let me break them down for you. This is in Japan for an average man who was born in 1990. They were likely to die at the age of 76. Whereas their health span, how many years they were healthy before a disease took over, that was on average 68 years old. So there's an 8-year expected period of disease and morbidity. If a person was born in 2013, the extended lifespan is expected to be by about 4 years, so now they're expected to live until they're 80. But their health span doesn't increase as much by 4 years, it increases 3 years. So there's an increase in their health span. So they will likely, in Japan, men will likely live until 71 years old healthily, and then spend the next 9 years, on average, living an unhealthy life. What about in the United States? The lifespan from 1990 was 72 for men, and for women was 79. Their health span was 63 and 67, so a 9-year difference here, an 8-year difference here of unhealthy years. For those born in 2013, there's an extension of 4 extra years in their lifespan for men, an extension of 2 extra years for women. And the health span increases 3 years. So you can see by the time that adults in the United States enter their late 60s, they'll likely live for another 9 to 10 years with disease. In Canada, we take this seriously. Very seriously. There is a campaign that has been out for the past few years, if you can see. It's called How Will You Spend Your Last 10 Years? And it's an image of a person either in a kayak or in a hospital bed versus a fisherman. And I'm just going to play you the commercial that we had on television and also online.
What will your last 10 years look like? Will you be quick enough for a game of tag with your grandchild? Strong enough to embrace every moment? with vitality, or get old with disease. It's time to decide. The average Canadian will spend their last 10 years in sickness. Change your future at makehealthlast.ca.
The first time I watched that, I think I cried. So now I try to restrain all of my tears when I watch that video. So on the same website from the Canadian Heart and Stroke Foundation, there are tips on how to extend your life by looking at some of the lifestyle risk factors. You'll see unhealthy diet, physical inactivity, unhealthy weight, smoking, stress, and excessive alcohol and drug use. I'm going to walk you through this, so don't worry about it. This is data from Ontario. Ontario is one of our provinces. We have 10 of them. And this is, in Ontario, the average age expectancy, this is 10 years old, this data at this point. The average age expectancy in Ontario was around 82 years old in 2007. And what you can see here is what does it mean to smoke? Or not smoke. So this is not smoking. How many years extra does it provide to your lifespan, or over compared to smoking, how much does it decrease from your lifespan? You can see that smoking has a serious decrease in the extent to which we'll live. There's data on alcohol, data on physical activity, data on diet and stress levels. And what do all the 5 risk factors provide, and what does it decrease from someone's lifespan as? And you can see over here that there's a 20-year decrease for those who are categorized as having high stress, not eating well, which for them from this measure was really just a questionnaire on fruits and vegetables that were being consumed, physical activity or physical inactivity, excessive binge drinking or drug use, and being a smoker. It decreases the life expectancy compared to those people who have none of those factors by about 20 years. What happens if you change your behaviors? How many extra years does it add to your life? And you can see that on average, by decreasing smoking and becoming a non-smoker, reducing alcohol intake, becoming physically active to the levels recommended by the CDC or the Public Health Agency of Canada, improving one's diet, reducing stress, will add approximately 10 years of life. So what's the take-home so far? Quality is equally as important as quantity is life. Health behaviors and stress matter. And I focus on the importance of physical activity. So Hippocrates, in a time when man was dominant, said walking is man's best medicine. I would like to say walking is a person's best medicine. And at this point, I have a quiz. So I'm going to ask you to do a show of hands. Usually if you go to see a talk by a physical activity researcher, they get you to stand up, and then you have to do like some jumping jacks, and I'm not going to force anyone to do that right now, but I will do a quiz. So the first question, and don't shout out an answer yet, is how many minutes of moderate physical activity are recommended per week? So a moderate activity level is 3 to 6 metabolic equivalent tasks. So the acronym is METs. 3 metabolic equivalent task is 3 times the amount of energy that's required to support movement and to support your body compared to just sitting. So the average for sitting is a 1 MET. So 3 for a MET is 3 times the amount of energy is required for your body to function while engaging in that behavior. Some types of examples are brisk walking, ballroom dancing, gardening, and water aerobics. I want to see who wants to take a guess of how many minutes are required? Over here. 150 minutes. She's right. I'm not asking her next. There's no way. In Canada, and this is actually from recommendations by the CDC and a working group, that it's required 150 minutes in total, spread out over 5 days, with 30 minutes during each activity. There's also the requirement that each one should last minimally 10 minutes. Okay, so how many minutes of vigorous activity are recommended per week if you didn't engage in moderate activity? Vigorous activity are greater than 6 METs, so it's required 6 times the amount of energy to do these types of activities. And those kind are jogging and running and swimming laps and jumping and so on. Jumping rope is actually, I think, a MET of about 10. It's considered one of the most strenuous activities that one could engage in. I will ask the same woman to answer this for vigorous. It's 75 minutes. So what is recommended is half the amount of time to engage 75 minutes per week, spread out over 3 days in chunks of 25 minutes, or a combination of the two. So somewhere between 75 to 150 minutes are recommended for for good health. So how many days of strength training are recommended? Anyone want to answer this question? 2 days are recommended for strength training. Muscle strength activities, 2 days per week. Here it says high intensity, but you'll see it also says moderate intensity. Moderate intensity is fine. For some reason, they're highlighting this high intensity because that's kind of where a lot of people really like to do some workouts lately. So moderate intensity of lifting weights, doing some lunges, doing works on your muscles and your bones. How do we fare in the world in terms of physical activity levels? So this is physical inactivity among adults across the world. You will see some very deep reds. Those very deep reds are greater than 50% of their populations self-report, and that's important, self-report that they are physically inactive. In the United States, it's somewhere between 30 and 40. In Canada, it's somewhere between 20 and 30. This is self-reported. If you ask people how much, they say in the United States, how much activity they do, it's about 50%, and that's consistent across practically every single study that I have read. Somewhere between 50 and 55% say that they are physically active in the United States. If you slap an accelerometer on them and track them for an entire week, it's somewhere around 20%. And that's consistent. In Canada, too, you have a 60% say they're physically active and 30% actually are. Children, I think, because children are required to do 60 minutes of movement per day. For children with accelerometers on them, it's 15%. So why is this important? Well, we've been talking about health span and lifespan, and I'll show you some data here on published recently in JAMA, published in 2015 by Aram and colleagues. And let me walk you through this. I won't ever put a figure on here without walking you through the results. Here you see some MET hours per week. So the minimum amount of METs is a moderate level in 150 minutes, and a moderate brisk walk is 3 METs. 150 minutes is 2.5 hours, so 2.5 hours times 3 is 7.5. So we have here, this is for the people who are just basically meeting the recommended requirements by the CDC or other agencies. The WHO has the exact same requirements. And this is if you multiply how many more. So this person's actually engaging in 10 times the amount of recommended physical activity. What does mortality look like? Look at this drastic drop just from becoming just by being physically active at recommended levels. There's a 20% decreased risk of early mortality. And when you get to this area of being 3 to 5 times, there's a 40% decrease. But the benefits of exercise don't extend just to mortality. This is from the UK government. This is the benefits of exercise reduce the risk of cardiovascular disease by 30%, type 2 diabetes by 40%, cancers by 30%, and so on and so on. So at the end of the day, there's a significant amount of research accumulated over the past many, many decades that physical activity is essential for disease outcomes, for reducing risk for disease, for decreasing the progression of disease, and for decreasing early mortality. And at the root of many of these diseases of aging, they're called diseases of aging, at the root of many of these diseases is our immune system. And And our immune system functions to keep our body intact, in check. It responds to physical blunts. If someone attacks me and I have a cut, my immune system will heal that cut. If I have a cold, my immune system functions better in order to deal with the virus or the bacteria. That's the importance of our immune system, and what they've discovered is that over time, our immune system ages. Exercise is known to benefit the immune system. Our immune system ages over time, and underpinning all of these diseases is a weathered immune system that is pumping up all this pro-inflammation into our body that's then circulating through our blood and attacking different areas of different physiological systems. And one of the markers of an aging immune system is the telomere. Has everyone heard here about the telomere? I'm going to do a little crash course that's going to take 2 minutes on what a telomere is. So telomeres are the highlighted yellow here at the end of a chromosome. The purple codes for DNA, and the yellow is simply a repeated sequence of TTAGGG repeated thousands of times. It was discovered by Elizabeth Blackburn from UCSF, and who won a Nobel Prize for discovering telomeres and also discovering the enzyme that extends that extends the telomeres every time a cell divides. And that enzyme is called telomerase. So the DNA, as many of you know, is transcribed into an RNA molecule, which then is translated into a protein. The blue, which was in the previous slide, purple, the blue is important for coding proteins. Damage, preferentially, when damage occurs to the chromosome, it preferentially occurs on the ends of the chromosome. So if you're going to damage something, let's damage something that doesn't code. So the telomeres don't code for anything. They're there to protect all the blue. They're there to keep the cell viable, to keep the chromosomes viable, to keep the proteins being produced as proteins that are still able to function well. But every time a cell divides, even if we have telomerase, the telomeres get shorter. And at some point, telomeres get to such a length that's so short that the cell stops division because it realizes that any more division, any more loss, will actually start affecting some of the proteins that are some of the DNA that's coding for some very essential proteins. So the cell stops dividing. Sometimes the cell dies, and sometimes the cell enters a state of senescence. Senescence is a cell that's not dead, and it's pumping out inflammatory proteins. And this is one of the root causes of diseases of aging, is the shortened telomeres. There's a debate always raging in the literature. Is it really important? Is it a marker? And there's some research really showing that this is a meta-analysis of the association between telomere length and cardiovascular disease. And here it says retrospective data. So this is data, studies where I have a whole room full of you, and you, unbeknownst, I've taken your blood. No, if you actually have to consent, and I'll take your blood. And I'll also find out if you have cardiovascular disease at this point. Across all these different studies, there's an increased likelihood of having cardiovascular disease at the same time of having short telomeres, an 80% increase in having cardiovascular disease. Here are some prospective studies. These are healthy participants across all these different studies. None of them have heart disease, but in the future some of them will develop heart disease. What is the risk of having short telomeres with developing cardiovascular disease in the future? Here, the increased risk is 54%. Similarly, we have risk for mortality, and here's some recent figure on the relationship between having short telomeres and having an increased likelihood of early mortality. And here there's a 54% increased risk if you are short compared to the longest group in this sample of participants. So what is the research on exercise and telomere length? Since 2007 or 8, there have been studies that have been published. Most of those samples have been small samples, looking at the relationship between self-reported physical activity, cardiovascular fitness, and also sedentary time and accelerometry-based physical activity levels. All those studies were predominantly showing that cardiorespiratory fitness, having a good heart and a strong heart and being able to take in oxygen and use it well, is related to longer telomeres. The physical activity literature, because of the sample size, I'd say in the majority demonstrated links between exercise and short and longer telomeres, but there were a lot of studies that were showing showing null effects. That's kind of changed with this nationally representative sample and Haynes. Larry Tucker went into the data. 5,843 participants had telomere length data, and they also had data on their physical activity levels. So they wanted to create different groups of physical activity, 4 different groups by quartile, the lowest physically active all the way up to the top 25% of most physically active. Sadly, he found that 0.8% of the participants reported 0 physical activity over the over the time that they were assessing. No physical activity. So he wasn't able to really do these quartiles that were evenly distributed by 25%. So he chunked out this 50%, and the remaining 49% were chunked up into 3 tertiles. And what did he find? What were the odds of having short telomeres compared to the highest group? So those who had 0 physical activity over the time of assessment had a 95% increased likelihood of having short telomeres in the sample. That's almost twice as likely to be in the short telomere group compared to the non-short telomere group. Those in the low physical activity group, so they engaged in some physical activity, but not a lot. In this sample, there's a 66% increased likelihood of having been categorized as short compared to the high group. And even those who engaged in a moderate amount of physical activity still had a 73% increased risk of having short telomeres compared to the high group. This has been repeated in a different sample in older women by Sadyab. They used data from the Healthy Women's Initiative study showing leisure time physical activity also being associated with telomere length, and this was also a pretty large sample. In the same sample, used data not from self-reported physical activity levels, but accelerometry measured physical activity levels. So that's when you slap on an accelerometer like a Fitbit or one that's used for research purposes, the Actigraph or the ActivePal or the ActivePal. There's all these different companies. They also found a relationship between the amount of sedentary time people engaged in, these women engaged in, and short telomeres. The more sedentary time, the more sitting around, the more sitting at the computers, not moving much, was related to telomere length, shorter telomeres. That was quite the study and got a lot of attention in the media. This is just one of the articles by Time magazine saying that sitting too much ages you by 8 years. That was their take-home message. My take-home message is that any exercise matters for your health span and your lifespan, but the effects can be seen all the way deep into our cells. But of course, more is better. That's my takeaway from here. So this says, for those who can't see, I'm prescribing exercise. Think of it as a stress pill that takes 30 minutes to swallow. Why am I bringing stress into this? So I'm a health psychologist, and I do a lot of work on stress. And the first paper I ever read was a paper not ever read in my entire life, but the first paper I read on the research that really excited me was this research by Alyssa Eppel about stress and telomere length. How do you measure stress? You can measure it with questionnaires. You can look at different events that happen in people's lives. You can look at their psychological experience. You can look at acute stressors like a hurricane, or you can look at a chronic stressor like caregiving. And Alyssa, Dr. Eppel, was interested in looking at family caregiving. Why family caregiving? Family caregivers there are 40 million family caregivers in the United States in 2013, putting in 37 billion hours of care, accounting for 470 billion of unpaid service. This is from the Alzheimer's Association or the Caregivers Alliance, kind of comparing what that $470 billion equals. It's similar to the money that's made at Walmart. It's more than the expenditures by Medicaid. Why is this important? They report 18 hours per week on average of care provision. 60% are caring for an adult while they're employed. 68% are using their own money, and 39% feel financially strained. 1 in 4 workers are 72% of workers are over the age of 40 providing care and still working. Family caregiving increases the risk for depression by twofold. It increases the risk for cardiovascular diseases twofold, and has an increased risk by 63% of early mortality. So as I was saying, Dr. Apple published the first paper that got me so excited, and when I heard her first speak about this research, and she's one of the most exciting speakers that I've ever heard in science, and I'm not saying that just because she's sitting here, she really is. She published this article in the Proceedings of the National Academy of Science linking short telomeres to life stress in caregivers. She had a sample of women who were premenopausal, who were providing care for a child for a child with a disability. She looked at she had a sample of these caregivers, and she looked at how many years have they been providing this care for the patient, for their child, and what was their relationship between the number of years that they were providing care and their length and their telomeres. And what she found was a strong relationship accounting for 20% of the variation in telomere length by the amount of years that they were providing care. So more years, shorter telomeres. She also found that if she had a sample of not just the red caregivers, but blue control participants who reported low levels of stress, or they were reporting low levels of stress and they didn't have a child with a disability, but they were mothers. And they also filled out a psychological measure called the perceived stress scale, and found that an increase across all the women in this study, an increase in their perceptions of stress over the past month was related to shorter telomeres. Since then, there have been studies on prenatal maternal stressors, early childhood adversity, and this list goes on, socioeconomic disadvantage like lower income, poor education, poverty, unemployment, domestic violence, and other papers linking psychological stressors and psychosocial stressors to shorter telomeres. The question for us became, what happens if you accumulate stress over your lifespan? Most of those studies have been one-offs, looking cross-sectionally at individuals who are currently stressed or reporting domestic violence, or and what their telomere length is right now. What happens over time? Do you accumulate stress, and does it get under your skin and embed itself and change the length of your telomeres? We had this opportunity to look at this question in a sample drawn from the nationally representative U.S. Health and Retirement Study. I'm not going to walk through all of this, but the Health and Retirement Study started in 1992 and has been tracking adults for the past, we're 2018 now, so actually for the past 26 years. There's different cohorts in it. There's 50 to 65-year-old participants, men and women, and there's also a 65 to 80-year-old group that tracked in the first couple of years. And as people dropped out of the study for health reasons or mortality reasons, or they just dropped out of the study, they kept reintroducing new cohorts into the study, and that's what all these arrows represent. There were 20,000 people at the start of the study on average, and in 2008, they got data from the saliva for telomere length. And what we did was we went into this 20 years worth of data, or 16 years worth of data, and tried to find all types of events that may be considered a stressor. Did they report unemployment at some time? Did they report financial loss at some point? And we looked through the questionnaire, and we found that there was at some point they also said, hey, what happened in your early life? And there were questions related to that they had to relocate when they were a child to a new home due to financial difficulties, that their father was unemployed at a certain point. So there were childhood adversities and then adulthood adversities, such as experiencing the death of a child, the death of a spouse, and also some financial difficulties in adulthood. What we found in this study was that none of these in adjusted or unadjusted or adjusted models, so we can ignore that. Let's look at the adjusted models, which means that in this model, I'm co-varying and controlling for everything under the sun. Their current education level, their current marital status, their current health behaviors, their current medication use, their current disease status. After adjusting for all those factors, nothing really alone dominated the length of their telomeres or predicted the length of their telomeres. But when you added them up together, there was a significant relationship between adding up and accumulating stressors across the lifespan and having short telomeres. And this was an 8% increased likelihood that for every one extra event, no event in particular, but for every one extra event, there was an increased likelihood of having short telomeres by 8%. So life stressors can predict the extent, the way that we age in a healthy way or an unhealthy way, but we also have factors that kind of make us more vulnerable or make us more resilient to stress. I look at healthy lifestyle predominantly and physical activity pretty much all the time, but there are other factors that we have examined to look at to see, do they buffer or mitigate the effects of stress on aging and our health? We've looked at psychological stress resilience. Are you a good emotional coper? Are you emotionally resilient? Do you not ruminate very much? And do you have strong social connections? And I'll show you the first study. So I was excited by Alyssa's paper, and I met her at a conference, and I think I harassed her for a good year, trying to convince her that we have to look to see if you're physically active, does stress still have an impact? So she's like, finally, come to San Francisco. I broke her. What we looked at, she had a new sample of caregivers. They were family caregivers, but they weren't premenopausal caring for a child with a disability. They were postmenopausal caring for a spouse, a parent, a sibling who had Alzheimer's disease or another type of dementia. And instead of looking at first I looked at the whole sample and found a link between, similar to the previous study, that greater amount of psychological stress, these participants, she also had control participants, so they were postmenopausal, not providing care. So the amount of stress that all these participants reported was similarly related to shorter telomeres. But I pulled apart, we had a few days of how much physical activity they self-reported at the end of a day, saying how much physical activity did you do. So I pulled it apart and found the participants who said none over those few days and those who said that they did. And I teased it apart, and fortunately, it was none or people met the CDC recommendation, so it was a good split to make. And what we found was that the relationship in those who were not physically active at all, the relationship between their psychological stress and their length of their telomeres was even stronger than for the whole sample. And for the ones who exercised, they may have been stressed, but it had no impact, or there was no relationship with their telomere length. But this is cross-sectional, and there are always problems with cross-sectional studies. So we then designed a study where we wanted to look at the determinants of telomere lengthening or shortening over a 1-year period only. And we asked individuals to report at the end of that year that we had blood from 2 different time points. We asked them to fill out a questionnaire on how many types of stressors may have happened in that year. Did they become family caregivers? Did they lose a home? Did they divorce? Are they having financial difficulties? And what we found was that for every extra event that occurred over that 1 year period, and some women actually reported 6 events over that 1 year period. This was a study in postmenopausal women only. What we found was that for each one additional event, there was an extra increased loss of 33 base pairs. Fortunately, we also repeatedly assessed their exercise levels, their diet levels, and their sleep quality. And we calculated it over that 1 year period. We summed it up, we made a score out of it, and we called it a healthy behavioral lifestyle. So even if they're stressed out or not, they might have engaged in high levels of physical activity, they may have engaged in low levels of physical activity. We summed it all up, we created this healthy behavior score. And what we found was, for the women who were stressed out, for the women who engaged in poor levels of health behavior, so they weren't physically active, they didn't eat very well, and their sleep quality wasn't that great, that the loss in base pairs per event was 55, not the average for the sample of 33, but it was 55. For those who engaged in the moderate, it was similar to the average for the whole sample. And for those who engaged in high levels of physical activity, those who ate well and those who reported good sleep quality, the amount of events, the number of events that occurred over that 1 year period had no relationship with the amount that their telomere length shortened over that 1 year period. We similarly looked at cross-sectionally in a sample of depressed participants, and what we found was that in depressed participants, that there was no real effect of our resiliency scores on the length of their telomere length. But when you looked at their resiliency, and I'm going to describe this in a moment, but since the figure's up, I'll walk you through this. For those who were depressed, if they were highly resilient, they had likelihood of having longer telomeres compared to those who are lowly resilient. And they had the shortest of all the telomeres, those who were low resilient and had depression. So what was resiliency in this study? Resiliency in this study was a mixture of, and it all sometimes based on the sample that is collected, and this was secondary analyses in a sample that was already collected. They had scores of physical activity level, and they had sleep quality. They had how good of an emotion regulator you are. Were you someone who avoided difficult emotions? And we also had social connections. So this is a combination of what that bubble was I showed you, this idea that you have these multiple areas that you can pull forth from for resiliency. Some of it being physical activity and other health behaviors, some of it being connections between one another, and also being a good emotion regulator. So what's this take-home message? Well, stress accumulates and reduces telomere length, but that exercise and other health behaviors and social connections and emotion, being a good emotion regulator, also matter for telomere length and health. Which brings me to my exciting findings I'm going to spend some time to kind of walk everyone through. So this was the FAST study that we got funding from the NIH to complete. One of the biggest problems with all the previous studies is that who are the kind of people who, when they have 5 stressors over a 1 year period, eat well, diet, sleep well, stay strong, socially connected, regulate their emotions with every single hit? It's really hard. So the biggest criticism, and I'm not saying criticism as in other than an academic criticism of this, is what happens if you take someone who is physically inactive and provide them the opportunity to become physically active? And that's what the FAST study was, which was this aging and stress study. And it was meant to improve the fitness levels in family caregivers. So I'll walk you through the design of the study. It was a pretty intense study. So they filled out a whole bunch of questionnaires, so ignore all this. They did a stretching trial, so we wanted to make sure that they wanted to participate. They had the motivation to participate in the study. So we asked them to watch a video for 10 minutes every day that was just stretching, and we created this video for them. And every day they said, yeah, I did it, or no, I didn't do it. And if they did 3 times that week, we're like, you know what, you're ready for an exercise intervention. They came in and we drew their blood. We did cardiorespiratory fitness, the VO2 max test, the stress test. Some of you might know about that test on the treadmill with the mask, and you're pushed to your maximal capacity. And they look at oxygen consumption, and they look at how well your heart functions during this test. We then randomized these 68 women and men into either an aerobic exercise intervention arm or a waitlist control group where they just waited for 6 months, and we asked them to maintain their low levels of physical activity, which some people were actually very happy to do. We had a few participants who were like, oh God, I'm so happy I didn't get randomized to that exercise group. So we then had them fill out a whole bunch of questionnaires, and I'll talk about this ecological week after, and then we had them come in and repeat all of these measures. How did we get them to exercise for 6 months? So this is with permission of our participant. This was our volunteer who was our fitness instructor or fitness coach, and this is one of our participants. He gave us permission to use this photo and slides. We met them, we gave them a 6-month free gym membership to any YMCA that was convenient to them. Paid for by us, half, and the other half was by the YMCA, was a donation. We met them at the gym. We walked through, this is what the next 6 months is going to be like for you. We provided them with an accelerometer to track their movement. And we also gave them a heart rate monitor because we gave them, based on their VO2, their stress test, we gave them their range of what moderate activity means for their heart and their heart rate. So it's called heart rate reserve, and we use the data from our lab, from our test, to tell them what their individualized heart rate goals should be. In the first week, you'll see we said, you know what, let's start off with 3 sessions of 20 minutes. Let's keep you at the low level of your heart rate reserve, which is this is your target, and this is some other participants' data. So we asked them to do 60 minutes of brisk walking. By week 9, we had them up to 150 minutes, and we had their goal at the 59% of their moderate zone. So we wanted them to stay at their moderate zone, keep them healthy, get them physically active for 6 months. On a weekly basis, as I said, they wore an accelerometer. They plugged in their accelerometer to a computer we gave them at their house. They uploaded their accelerometry data. We downloaded it from the cloud on our end, and we turned it into a pretty report saying, look how much light activity you did this week. Look how many steps you did. Look at how much moderate activity you did, and look how much vigorous activity. And we counted how many minutes, and then we would send them an email, and then we tabulated it, and we showed them week by week progression. And we sent them an email with this report saying, congratulations, you did 199 minutes this week. Great job, keep it up. If you have any questions, please let us know. For those who didn't maintain or attain the 150 minutes of our goal, we said, congratulations, you did 20 minutes. It must have been a tough week for you, but you still did 20 minutes. Let's talk about facilitators and barriers to get you going for another week. 5 times a week, we sent them text messages. Different types of... One of our participants said, I don't think you can write 5 times 24, so what's that? 120 brand new text messages through 6 months. And we said, you'll see. And we sent 120 unique text messages 5 times a week for 24 weeks to these participants. Today is a great day for a walk. Meet a friend for a brisk walk instead of coffee. If they didn't reach their goals, we also scheduled a phone call, and we used motivational interviewing best practices. This idea that I can have a conversation with someone, or at least I trained my coaches how to do this, have a conversation around what are your goals? Do we need to adjust your goals? What helped you get out for those 20 minutes this week, and what made it difficult for you to not reach your goal this week? And we then strategized with them on methods to overcome those barriers and how to use that information that they said made it easier for them to overcome their barriers. It was an intense study, and it paid off. What did we attain? We attained approximately 73% of participants reached our 150-minute goals per week. That's pretty good for an intervention study in high-stress caregivers who at this point had been doing nothing. I was told by someone, you're likely to get 5 people in this study. But we got 68, and we got 73% of them to reach their goal. If I looked at 120 minutes, so reduce the bar a little, but this is most interventions go for the 120-minute goal. What we found was that 81% of participants reached their weekly goals at 120 minutes. That's pretty good. We improved their cardiovascular fitness, so their VO2 peak, which is their ability to use oxygen and how much oxygen is being consumed. We improved their VO2 peak in the exercisers, and not surprisingly, in the control group, it didn't change over a 6-month period. Went down a little, but not significantly. What about their telomere length? This is in the control group. There was a slight decrease that was not significant. And in the exercise group, their telomeres lengthened by about 60 base pairs. And this effect, so when you do a trial, you first have to look to see whether the effect between the groups is different, and the effect is significant. What happened in the exercise group was significantly different from what happened in the weightless control group. Fortunately, the weightless control group also received the gym membership and some support at the end of the study. We also changed their perceived stress levels. So stress plays out, caregiving plays out on a daily basis in these individuals' lives. So we use this technique called ecological momentary assessments to assess how they're feeling and what they're thinking during the day. Ecological momentary assessments, people wake up, they go to sleep, and we kind of chunk up their day into 6 intervals. And during that day, we'll ping them in the morning and say, hey, how are you feeling right now? How much control do you feel over your life? How much ruminating are you doing about stressors? We do it 6 times at random times during the day, and we do it for a whole week. And you'll see it's just randomly split. Our days are chunked up equally, but it's randomly sent as pings to these participants. I'll present some data on what happens at each ping. So at each ping, we assessed how much control they feel over their lives. We assessed how much ruminating they're doing about stressful situations. So have you been unable to stop thinking about stressful situations? And that was asked at every single time point. And we asked about their negative affects, so looking at their anger, their anxiety, whether they're feeling embarrassed, some fatigue, frustration, some loneliness. What did we find? We decreased rumination in the exercisers. They went down a significant amount in how much they ruminated, whereas the control group stayed the same in how much they were ruminating on a daily basis. We shifted their controllability. They felt more control over their lives on a daily basis throughout the whole day in the exercisers compared to where they were 6 months earlier before they started the intervention, whereas there were no changes in the control group. And we reduced their negative affect. And in fact, the exercisers went down in their negative affect and how negative their mood was on a daily basis, whereas the control group went up. So what the take-home is exercise improves traditional and novel markers of health and improves how we experience our days. And it gives us an understanding into how our motivation, the barriers and the facilitators that we experience, how they affect our health behavior change. And it's important, it's essential that when we think about our own changing of our own behaviors, it's essential for us to really sit back and think, am I able to do this? Am I motivated to do this? What are the barriers? It's so cognitive, and boring sometimes to go through this, but it actually works. What are the barriers that I'm facing that are stopping me from exercising tomorrow or eating well tomorrow? And what will help me to get through it? And this is a constant reevaluation. Another really boring thing that people have to do in order to become physically active or eat well is scheduling. All of us are really stressed out. We thrive on telling each other, I'm really stressed today. And we think that all of a sudden at New Year's or all of a sudden at our birthday, that we're going to change everything within the context of feeling stressed out all the time. And part of it is we don't take care of ourselves when we're stressed out, but we also don't make the time to take care of ourselves. And it's quite essential when you're building a new practice to look at one's calendar and think, where am I going to fit this in? And how does this become as much of a task as washing dishes, as getting groceries? How do I make this a task in my calendar? Which sounds so boring, but it's essential to build a new behavior. How do you make that a task so that you can start following through with it? Another important thing that scientists have learned about what keeps people exercising is how good you feel during the exercise and after the exercise. People who push themselves in that first week of not having worked out for 6 years, and they're like, I'm working out, and I'm going to go to the gym, and I'm going to spend 3 hours there, and I'm going to take the aerobic class, and then I'm going to take the step class, and then I'm going to do the weights, and then the next day they're in pain, and they didn't enjoy those 2 hours, and their body's aching, and they did not enjoy the experience because they also pushed themselves. They took CrossFit all of a sudden. They decided that CrossFit was the thing that they're going to do. But their body wasn't ready for it. But psychologically, their mind wasn't ready for it either. There's actually research showing that once you pass the level of how much oxygen can be consumed compared to carbon dioxide pushed out, at that level, and that's in the high intensity zone, at that level, you move from exercises feeling good to exercises feeling bad. And it's at that point what is called the ventilatory threshold. When you surpass or pass that ventilatory threshold, you now are not feeling good. And that has been shown that when you pass that and you're reporting after that I'm not feeling good or it wasn't that great, that feel-good feeling is predicting future engagement in behaviors. So if anyone here is planning on changing a behavior, don't push yourself too hard in the beginning. And then if you need to and you start enjoying it, your ventilatory threshold changes as you get more fit. Just keep pushing yourself a little bit more. So what are the next steps? Well, from a biological perspective, there are all these telomeres are protected or elongated by the telomerase enzyme and protected by all these different proteins that make up this sheltering complex. We know from rodent literature and from just one acute bout of exercise in the lab that all of these protein transcriptions, so the amount of protein in the cell of these proteins, or the amount of protein of these in the cell, we know that this goes up to even one acute bout of exercise. So in the future, what we're hoping to do is look to see if someone exercises for 6 months, are we changing the basal levels of these proteins over a 6-month period, or is it just in response to stress? We're also taking people and we're putting them in a treadmill test in the lab, and we are putting them at different levels of physical activity. So some are at high intense levels, some are at moderate intensity levels, and some are at low levels, and some are sitting. And then we're stressing them out in the lab. And we're with this stress task, which is kind of like this, where someone's giving a speech, but none of you are laughing, and none of you are enjoying this talk, and all of you are staring at me blankly. So this is a task that is done in the lab, and what we are hoping to look is what is the effect of different levels of intensity on how we feel after the task, and all of the hormones that flood us, like stress hormones, the cortisol, or our heart rate going up. Does exercise kind of mitigate some of that stress response immediately after you work out? And we're also going to play around with how much time is happening between the exercise bout and stress. Does exercise only have an effect 30 minutes later on the stress response, or does it last 3-4 hours later too? And we're also taking all this work into children. This is a recent movement in Canada, this 24-hour movement guidelines. So instead of just looking at exercise levels in children or adults, our day is actually made up of 24 hours. So You increase exercise or you decrease exercise, you're increasing sedentary time or you're decreasing sedentary time, and you're changing sleep too. So our day is actually made up, and a child's day is made up of sweating and stepping and sleeping and sitting. And there's recommendations for 60 minutes per day per child of sweating, doing some moderate to vigorous activity. Stepping for 60 minutes per day, or several hours actually. How much sleep is required? 9 to 11 hours of sleep, of uninterrupted sleep in 5 to 13-year-olds, and 8 to 10 hours in 14 to 17-year-olds. And to reduce sitting in children to less than 2 hours per day, which is almost an impossible task with sitting at school. But that means when they come home from school, reduce the amount of sitting when they come home from school. So, that's my conclusion of this talk. Start moving. And I want to thank all of the funders, the NIH and the Alzheimer's Association, for funding my projects, CIHR in Canada, and Innovation, which funds my lab up in Canada, all the infrastructure, and all of my amazing collaborators at UCSF and UBC. Thank you.